Is on how to reduce fractions by it says canceling common factors. That's the lingo from this textbook, but we would just say by reducing. And so essentially you have fractions that are not monomials, or they're only one of the numerator, the denominator is a monomial, and so we need to always factor, and then you can reduce. And they say canceling common factors, but you can reduce the common factors, but you always need to factor first. So the thing that the mistake people often make, and they forget and then they do it again, is they go, oh, I know 2 goes in there, I can cancel that out. And we talked about that with radicals. You can't take a 2 out unless you can take it out of everything. So you're just better off factor, and then you can reduce out of there. Okay, so the same is true when you get to one that just has variables. You can still factor out a variable as a common factor. That leaves you with y plus z all over x. So I can reduce that out of there, so just left with y plus z. I know this paper's a little crowded. You may need to write it out on your own a little bit. When you get to one like this denominator is already factored. The numerator, I always start to kind of cheat factor a little bit. I know there's an x minus 4 that's probably going to have to cancel out. So I should probably get an x minus 4 or a 4 minus x up here when I go to reduce this. So I take a 3 out, I get x minus 4. One of the x minus 4's cancels out. Leaves you with an x minus 4 there. 3 goes into 6 2 times. Make sure you leave it as a fraction like this. Don't just forget that the 1 doesn't, people don't want to write the 1 there. You need to make sure you write it. Okay, so all of these, again, simplifying by, some of them are already reduced, some of them, if you forget, x plus 3 squared is x plus 3 times x plus 3. Write it out that way. And then when you go to cancel, you don't mess up your rules. Okay, so these directions here just say simplify. The other one said simplify by canceling common factors. Well, you're going to have to do the same kind of stuff. So let's skip around here a little bit. Let's look at f right here. So my rule is factor the numerator and denominator. I know there's the greatest common factor of x. And then I can cancel that out. And the paper's kind of crowded. Do it on another piece of paper if you want. Make sure you leave it. This is a dangerous one. The numerator is already factored. The denominator, I can take an x out of both, and it leaves me with b plus c. So the x's cancel out, but your answer is not b plus c. It's 1 over b plus c, and that's a big difference. Okay, so you can finish those. Those are a little more straightforward, and we'll go to the second page. And really the only difference is the factoring gets a little bit more intense. Most of these are just going to have a single factor that you can take out. But when you get to any of these squared properties, let's look at n. You use your rules of factoring that we did the whole first semester. So I know that this is the difference of 2 squares, so I know it factors into x minus 2, x plus 2. Now, this is not x minus 2, but I want it to be x minus 2, and you can switch. This is a key strategy here. You can switch by taking out a negative 1. Because if I distribute this back through, I get negative x plus 2, which is what that is right here. Now, you can reduce, and then we're out of room here. If you had x plus 2 over negative 1 as your answer, then we can distribute this negative 1 through here. Don't leave it as a fraction with a negative 1. You can divide by negative 1 because 1 goes in there. Again, ones like this, be careful, because when you factor out the denominator and you go to cancel with the numerator, that's the easy part. Don't forget to replace that with a 1. Nothing crazy down here, just you get a little bit more factoring I'll show you this one. Take out a 5, x squared minus y squared. I can take out a 10y here. Leaves me with x minus y. Again, don't cancel being crazy. You know you're not done factoring x squared minus y squared. That equals x minus y, x plus y, x minus y. Now I can go and cancel that out. 5 goes into 10 2 times. Make sure at the end you rewrite your answer. If you have a denominator that is a monomial, like this one, you could divide this and write it as x over 2y plus a half. You don't need to. I would just leave it as a fraction so you don't make it unless it's asking for some other form. And then again, the only thing that gets a little more complex here are the factoring values. And so for any of these quadratics, some of you use the x method, that's fine. I'm going to encourage you to keep trying, guess, and check. So you can use the x method here if you want, but I know there's going to be a 2x and an x. And your x box gets you x minus 4, x plus 2 really easily there. But I know there's going to be an x minus 4 or an x plus 2, or I think there is. So that helps me kind of cheat factor a little bit. Well, I know 2x and x can only give me 2x squared. I need something to give me 4. So either 2 and 2 or 4 and 1. Well, try it. And try 2 and 2. That's 4, or that's 2x and 4x. I can't come up with 7 using any method there. So I'm going to try 4 and 1. And I put the 4 over here because if I put it over here, you'd have to factor out 2. That usually is not how it works. So now I have 8 and 1, which is 7. So minus plus. Okay, so that cheat factor rule kind of works. And thinking that you know that they're wanting you to reduce stuff, so there's a good chance that factor will be there. The rest of them, there's not really any. The only thing that gets more complicated are the amount of factoring that you have to do. Be careful if order changes. Remember, if you want to change a 2 minus x into an x minus 2, that's how you change it. You didn't really change it, you just make the form a little different.